Okay, we're now recording, and this will go up on YouTube. And we usually edit out the question and answers, so don't worry about if you don't want to appear on camera. We're going to cut that part out. Okay, this is something that I've been really excited about as soon as I saw this project, and then when I saw Ben was presenting in Toronto, I jumped. I jumped almost too fast to get him to show up here. So I'll let Ben do the rest of the introduction.
Okay, great. So we're going to talk about right now, I put it in the presentation mode, so I can't see any of you guys. But we're going to talk about SQL, and we're going to talk about Elixir and how we can have better foreign language integration, because that's usually always the issue, regardless of what language you write in. Foreign language integration is always like, it's a mixed bag. Sometimes you're lucky you write in a language where you have, where you can talk to like C directly. We can do that too in Elixir and Erlang with nifs. But for something like SQL, yeah, that's, you tend to end up just with an ORM, which is like somewhat in between everything, and not really a foreign language that's integrated in your general programming language. So that's kind of the idea with SQL. This is like we want to give you a better experience than what you get from an ORM. We want you to give like the full experience. We want to follow key software engineering principles like separation of concerns, which I'm sure everybody who has worked with SQL and worked with application code and ORM have run into this, where like the ORM is just lacking in the way to express yourself, right? So how do we do this? That's pretty much what we're going to talk about. How do we make it so you can express yourself without any cost in performance in whatever way you want to do that. So let's take a look at some examples here. What's the difference really from Acto and SQL? So here we have like a typical function. You've probably seen some Elixir code. You are taking out all these users, you're mapping them. You want to get this username capitalized, and then you want it to format it in a way. And this is obviously like an extreme example, but it's just to showcase you, like, this is like literally the only thing we can do when we use this repo is like type it into enums and one after another. And that's problematic because like you make intermediate list, so that is not very performant. Obviously we could do it in one go here too if we put it all in, but we're just trying to showcase something, right? So let's see, we can do that too in SQL, but you get this separation of concerns with like, you keep your SQL, all the things that happen in the database stays in the database in the query, as you can see. And then when we pipe it to the map function, we can pipe it in as many as we want, and it would still be executed just once. So this is like, it couldn't be better. There's no foot guns where you end up doing an intermediate list, right? Which is great. And you can even use your own repo to load into your active schemas. That's kind of the idea here. It's like keep SQL, and then keep your transformations in Elixir. I'm sure you all have used active select, which is like that can be a weird one, because like not only can you transform the results set in SQL, but you can also transform what's come out the other end. So like it's like like sometimes you think you can do something that you can't because it's not implemented. So there's all these foot guns, and you don't really know when it's going to be SQL, when it's going to be Elixir. Here we have a clear separation of concern. So that's kind of that, and obviously those were extreme examples. We can do better. This can also be kind of done in Excel, but it just goes to show, like no matter what you do, no matter how you hold SQL, we will always try to do the best thing for you, performance-wise and expressive-wise. For the really SQL pro here, like obviously all this is something you want to do in the database, right? So here again, I'm showing you that you can just write it here. It doesn't matter because like what you see is what you get. So if there's something that's special to the database you use, you just put it in, it will just work. No issues there, right? So let's do a little demo of that. That was not actually what I wanted to show you guys because that's something to work on. So that was a sneak peek. But here we have a application, right? And in this application, this is an application that has a mix, but we basically have two functions here. And what I want to show is like we have this get user where we have something, first of all, we have something that doesn't really, it seems like a little bit weird, right? But it's just to showcase what kind of errors you can have, right? So when we start here in this query, I can tell you up ahead that the users, the columns and all that, they do not exist. There's no user tables in this database. So what we want to see is we want to see that it errors and tells us, oh, there's some missing relations to give some indication of we might need to run our migrations. And in the second query, there's a URLs table, so it should not error. So let's start this application, and there we see it went fast. We got a warning. We can see there's no OPS relation, there's no email, and there's no users, and it's all highlighted since I got it, so we can actually, it's easier to read. Typically, when something happens when an error is raised in Elixir or Excel, it's usually all red. And for me, I have a really hard time just having to ask what's wrong when everything is red. So we're trying to do a little bit better. And that's pretty much it with that. So let's try to see what happens when we do this mapping, because we have a URL struct already. So let's do that because we want to see it works, and I'm just not making this up, which I could be, but here we go. So we are mapping this into the actual struct with no problem. And you can see the query that's been executed. See how long it took. So that it works. It's nice. We can even I can even show you when we create that log file, which we use to generate these errors. So that's just run it. Bang. We created a new log file. We generated the log file by query the database, and you see we are still warning if we see anything. Okay, that was a little demo. Let's go back to the email. So when we want to build something like a compiler and a parser, it's very important for your project maintainability to be conformant. Because the worst thing is that you change something in your Elixir, you change something in your parser, and then you have a minimal test suite that do not catch it, and then you're simply relying on user reporting these errors if you don't find them. So we use conformance testing, and there's this guy Elliot Chance who wrote the SQL test. It's being used by ClickHouse too, which he's been, some of it is done manually, parsing the whole grammar from SQL 2016, and then generate tests. So I made a little mistask to make my life easier, and this is like the conformance testing. This getting generated. There's more than this, but this is the clearest one. So basically, what we do is we take the SQL. We want to see what you see is what you get. So that's basically it. We want to make sure that we preserve the user's white space in any way, because by doing that, then we don't need to worry about any functions that are not implemented in the parser. So that could be like that could be database specific. Like we can completely avoid that with just being what you see was what you get, and then hopefully there would be no issues other than if you've typed something you shouldn't have typed. So that's how we stay conformant and know that we can generate the proper SQL that we want to send to the database. Very important when you do like a project like this. Obviously, when we do something like this, we need to benchmark it, because like there's nothing worse than building something that's slower than what there's already is. So here I'm showcasing extreme example again, but this is the reality when you do CTEs in Exo. They are just ugly. They are no matter how. Yeah, I've never found a way that you can write them nicely, and all of this actually came out from me working in a big company where we had dedicated DBAs, and when I have in my backlog a query that's slow, I wouldn't have time to figure out that myself. So I would just send the information to the DBA, and thank God they would solve it, and I would get a SQL back. And then now I have two problems, because now I have something I need to translate into Excel, which is, I don't know, it's like, I think life would just be so much better if we could just write the SQL and just interpolate the Elixir if we want to, and then have some checks on what we're doing is correct. So let's see how this benchmark, just generating the SQL, because that's, we want to know that we're not slower than Exo than that. And clearly we see Exo generating strings and SQL takes a long time. That's because we use a schedule and can do a lot of work on compile time, which Exo cannot. Exo does everything at runtime and use a lot of structs, which is very expensive performance-wise. Like, you might think, oh yeah, but you're piping one thing into another in the Exo example, and your example is just like one schedule. So what is the cost if we had to do something similar, where we had some composability? So we can do that too in SQL. We can pipe. It doesn't really matter. Like, you can do from first, select first, whatever you want. Like we really try not to limit your expressions enough, because like that's just a no-go. Because sometimes I can't remember what is it to go first. Is it select? Is it from? Does it really matter? Why does it matter? I don't know. Nobody's really clear. Have really told me why is it that select has to be first? Why can it not be from? But again, no problem. We're still faster. Obviously not as much as before, but like, doesn't really matter when we're talking nanoseconds, right? That's just nice to see. We can do again. Let's just inline instead of have interpolated, right? And see, does it change anything? and obviously it does. Again, this just again to showcase the expressiveness of SQL versus Ecto, and the performance gain you would gain and doing these things at compile time. Let's do it again to see, like, is there any difference, right? Of course there is. You know, I've been hammering this pretty much in. We can do this again, like whatever you want to do. Like, you will, like, we will never limit you. We will always try to make sure that nothing is slow. And we can take this further, and then we can say, right now, in this extra example, this is kind of, it's more or less what we do in the enumerable. So let's see what's faster here when we benchmark these two functions. Like, and we see all that work actually paid off. We are a little bit faster, not by a lot, because obviously latency to and from the database will always be a major performance killer. But again, we're still faster. It's amazing. It's very nice to see these things, right? And then we come to the bug. The bug in Elixir. It took me a little. Like, I did a lot of changes to my AST, and it came about because the way that I built the AST is very similar to Elixir's AST. It's a tuple. It's a three-element tuple where, like, you would have the keyword's name first, and then you have metadata, and then you would have a list of that could be a list of values. So the problem started with this query where we had select A from table where A likes foo, escape it, right? We got this issue. This doesn't tell you a lot other than apparently our our tuple here where we contain some information about where a token is couldn't be escaped. Okay. Then let's look at the whole AST here, CST. What could that be? Why is it? What is, like, so special about that? And if you know about the Elixir AST, you will notice, oh, maybe it's that growth thing, and that's actually the issue here. Like, I'm having a name that's similar to Elixir AST, and then macro escape kind of wouldn't like that I had a list with one character, so it didn't really know what to do to that. This is fixed in Elixir 1.19. But yeah, this bug had been here for a long time. I'm also probably the first one to build like an ST that looks so similar to Elixir. There's an issue you can go in and check if you want to read the history. It took a while. It's pretty complicated. That macro escape function is pretty wild. I didn't even know where to begin. That's pretty much it for this. But I want to talk about the future of the library, and I want to showcase the newest thing I'm actually working on. And the future of SQL, I had kind of hoped that I was going to use Ecto more, but I've run into this issue where Ecto is so tightly coupled to the connection pool, DB connection. And right now, I cannot leverage prepared queries in Ecto's connection pools because they generate references and all that. And in SQL, we generate ID for each query, so we have a global unique ID, so we know exactly how many queries you have. We can prepare them. We can make sure that we hit 100% cache hit on your connection. So you never get a cache image mix, which is probably the most important thing for performance. And that would just generally excel. So I asked Jose if we could do something, but like the problem is that again, Ecto is all dynamically, and they don't have a way to generate a unique ID at compile time. Um, so so I'm I have the pleasure. I have to implement my own pool, and I want to show you a little bit about the pool implementation and where we are. So I started out. I hope you guys can see this. Is this big enough? Hopefully this. So I started out with saying, I want to make the best pool we can make. Because why build it if we can't do anything better? So what we're trying to build is a completely log-free pool with a complexity of constant time, right? That's probably the best we can do. And to be able to kind of work on database pools, you kind of need to visualize it because it's really hard to know or identify any contingent issues, or just how it gets utilized. So I wrote a little benchmark visualization, and we can run that, and then we can see it go through. So let's do this here. So we're running the benchmark right now live, and we can see we have it's a countdown 15 seconds, and the pool is initially started at 10. It's still at current 10. We have a recommendation. We're trying to use Little's law to recommend pool size. We have a little bit of hysteria in it, so if there's only a difference between two, we don't really care. We just if there's more than two in difference, then we would resize or either grow or lower. And here we see the scheduler. So we have 10 scheduler, or I have 10 scheduler, and I have 10 connection, and we can see that the work is pretty even on the schedule and also on the connection. So that's why we get so high performance here, right? So we are banging it. So this is a great way to visualize a pool because we want to try to put it through some different simulation to kind of see where's the problems, right? This one is very simple. Right now, I don't have any debt, but I'm still working on that because we wanna simulate what happens if this connection is dying. What do we do if there's high error rate and retry rate? But this is a great way to kind of just visualize, and we can see the pool is very fast. Like the least time is very slow. We're just hammering through. And this pool, I'm aiming for this to be way faster than DB connection, and also be more resilient and be able to just dynamically resize and adjust. So this is the first step to be able to actually have this 100% cache efficiency. So that's where we are. I don't know. Is there any questions